Hey there, this is Randy. Today we'll be using our knowledge of factoring to divide quadratics by linear expressions. As a general rule, before you watch me do a problem, I encourage you to always pause it and try it yourself first. So right here we can see the 5 different factoring techniques that we learned in the factor higher degree polynomials video, and these very well could come in handy as we're trying to solve the problems today. So we need to do a division, but before we can divide, let's see if we can factor the numerator somehow. Well, it looks like there is a GCF between 16x squared and 4x. When we say GCF, we're talking about greatest common factor, as a reminder. So what is the GCF between these two terms? Looks like they have a 4 in common and also an x. So let's rewrite this fraction with the 4x factored out. So we have 4x, and then 16x squared divided by 4x will give us 4x. And then we have minus, and then 4x divided by 4x is 1. We still have in the denominator 4x minus 1. If we write parentheses around this denominator, it's the same. Just so that they look exactly the same, we'll leave those parentheses right there. And now we have a 4x minus 1 on the top and bottom, and so we can cancel those. So 4x is the only thing we have left over, so we can just write that 4x is the quotient after simplification. So this next one here, again, as usual, is going to require factoring, but it's going to be a different kind of factoring. What could we do here in this numerator to factor? It looks like a sum product pattern. Let's see if we can find the two binomials that will come from this trinomial. So we're going to write 2 parentheses right here and then 2 more parentheses here. And based on what we learned in the video about factoring higher degree polynomials, we're going to write an x and an x right here. And now this term and this term multiplied need to be 35 and added need to be negative 12. What two numbers are those? That's going to be a 5 and a 7. 5 and a 7. And they'll both be negative because negative 5 times negative 7 is 35, and negative 5 plus negative 7 is negative 12. So now we have the same denominator as usual. So we're going to write, once again, x minus 7 on the bottom. And let's put parentheses there so that it looks the same as what we have on top. And once again, we can cancel. So x minus 7 can cancel on the top and bottom. So the only thing that we have left over is x minus 5. X minus 5 is the quotient of this original expression after we simplify. All right, let's do another example here. Hopefully this numerator looks familiar because we have a apparently perfect square. We'll find out for sure if it is a perfect square soon. And we have a perfect square again on the right, and we have a minus. So this is a difference of what? It's a difference of squares, we think. Let's see if we can factor this. So the difference of squares, if we remember from the factor higher degree polynomials video, a difference of squares is like this. A squared minus b squared can be rewritten as 2 binomials, a, b, and then plus minus. And because of the commutative property, you could write this binomial before this one, and it would still be the same value. So let's see if we can apply this logic to this difference of squares right here. So first of all, let's write our 2 binomials. So we have one binomial and another binomial. And what is the principal square root of 9x squared? Well, principal square root of 9 is 3, and principal square root of x squared is x. So it's going to be 3x. So 3x is like a, and that goes as the first term in both binomials. There it is. And then the principal square root of 25 is 5. 5, 5, and plus minus. Now we have the same thing on the bottom in the denominator as before. So we still have 3x plus 5. So now we have a 3x plus 5 on top and bottom, so we can cancel those. So goodbye, goodbye. And the only thing we have left over now is the 3x minus 5 that was on top. 3x minus 5 is the simplified quotient of the original expression. Now, if you see some problems that are different than the 3 examples that we've done today, maybe they will require some other type of factoring that we learned in the Factor Higher Degree Polynomials video. So you can always go back to that video and review. And with that, we are finished. See you next time.